Hey students, this is lesson 10.2. In this lesson we're going to learn how to find the area of a trapezoid, a rhombus, or a kite. Go ahead and do the review to make sure you remember what those are, and I'll check back with you. All right, here's some important formulas for you. The area of a trapezoid is half the product of the height and the sum of the bases. So the bases of the trapezoid are the ones that are parallel, and the height of a trapezoid is the perpendicular distance between the bases. So let's go ahead and use that so we can get used to that. What is the area of this trapezoid? So the area is equal to 1/2 the height times the sum of the bases. So let's just substitute in for our height. This has a 45-degree angle, so we're going to have to use that to help us find the height. So our height would be right here. And a 45-45-90 triangle, which is what this would be, has some special properties that we can use. This little distance right here is 14 minus 8, which is 6. And since it's a 45-45-90 triangle, we know that the legs are congruent. It's an isosceles triangle, so the height is 6 also. So we're going to take 1/2 times 6, and then the sum of the bases. The bases are the parallel sides, so that would be 14 and 8. Half of 6 is 3, and 14 plus 8 is 22, and 3 times 22 is 66. Labeling that since it's area square millimeters. Go ahead, you try that. All right, find the area of this trapezoid. Again, we need to use the formula. The area of a trapezoid is 1/2 the height times the sum of the bases. Okay, we have the bases part. We need the height, and in this one you might notice that there's a 30-60-90 triangle there. So we're going to use those properties to help us on this one. And in the 30-60-90 triangle, all three sides are related in a certain way. We can find this side by just doing 7 minus 5, which is 2. Okay, and in a 30-60-90 triangle, the hypotenuse is double that, so that would be 4. And then the longer leg is square root of 3 times the shorter leg, so 2 times the square root of 3, and that's our height. All right, so now we have everything we need. We're going to do 1/2 times 2 times the square root of 3, and then add the two bases up, 5 plus 7. And simplifying that as much as we can, 1/2 times 2 is just 1, so it's square root of 3 times 12. And we might as well leave this in simplest radical form. We'll just say 12 times the square root of 3. Just in case it's needed, we'll round this to the nearest 10. And that's about 20.8 square meters. All right, go ahead, you try that, and I'll check back with you. All right, the area of a rhombus can be found by taking half the product of the lengths of its diagonals. So describe one way that finding the area of a rhombus or kite is different from finding the area of a trapezoid. Think about that one. All right, so the area of a kite is 1/2 the product of the diagonals. So in this one, we got to find the length of the diagonal. So the length of this diagonal AC is 2 plus 8, which is 10. And the other diagonal is 4 plus 4, which is 8. 10 times 8 is 80, times 1/2 is 40. And we'll label that square inches. Go ahead, you try that. Okay, find the area of a rhombus. Again, the formula for finding the area of a rhombus is 1/2 the product of the diagonals. So we need to know the diagonals here, and the diagonals of this one will be the same as this distance here, so 8.4, and the other diagonal will be 15.5. So we can just substitute those in. 1/2 times 8.4 times 15.5. And simplifying that, we get 65.1. And we want to label that square meters. Go ahead, you try that. All right, here's the lesson check. Go ahead and do that, and we'll talk about this next time we meet in class.